Today we are going to discuss the section 2.5, which is existence and uniqueness. Okay, so what are we going to discuss in this topic? So let's say a system which has been given in this form, x dot is equal to f of x. Now the question is whether for such some f of x has been given, and for that f of x, whether a solution which is x of t, whether that solution exists in the first place. Okay, so that's the existence. Okay, and if it exists, then is that solution unique? Okay, so those are the two things we are going to discuss under this topic. Okay, so first we will see an example. Let's say x dot, one second, x dot is equal to x to the power of minus 1, not minus, is it minus? No, Control C, okay, just 1 by 3. Okay, and this is the Gaussian differential equation, and the initial condition, which is x naught, which is equal to 0. Okay, now for this case, what is the solution? So in order to calculate the solution, let's put let's use the analytical approach. So in the place of x dot, let's put dx by dt, so that what do I get? X to the power of minus 1 by 3 dx, which is equal to dt, right? Now let's do an integration on both sides. Okay, what do we get? So this will provide a solution in this manner, which is 3 by 2 x to the power of 2 by 3, okay, which is equal to t plus c. Okay, now if in order to calculate this c, we need to impose this condition, and if we impose this condition, we will get to know that c is equal to 0. So finally the x of t, I could write x, which is equal to 2 by 3 t the whole power 3 by 2. Okay, so this is the solution. Fine. Now if you see, x will keep on increasing as t is increasing. Okay, so that's what the solution says. In another perspective, if we see this equation once again, the initial condition, initially x is equal to 0. When x is equal to 0, what is x dot? So put x is equal to 0, x dot is also 0, right? If x dot is 0, then there won't be any change in x, right? If there is no change in x, then x is going to remain in 0. Okay, so here using this process, we have obtained one solution, but there is also a possibility of another solution, right? So what does this mean? It means there is a problem with the uniqueness. Okay, there is a problem with the uniqueness. So how can I make sure whether a given function f of x will provide me a unique solution or not? Okay, so what is the condition? The condition is as follows. Okay, what we have to do is we have to take f of x and f prime of x, and if these two functions are continuous, okay, continuous at x naught, okay, if these two functions are continuous at x naught, then I could say that in an open interval which is near to x naught, the solution exists and the existing solution is unique, okay. So that's what it means. I mean, that's the condition for the existence and uniqueness. Okay, let's put this function to test. Okay, so this is f of x, and what is f prime of x? Let's say f prime of x, which is equal to 1 by 3 x to the power of minus 2 by 3. Okay, so one equation f of x is equal to this, and f prime of x is equal to this. Let's plot this and let's see whether this is continuous at x naught. For us, x naught is 0 for this case, right? So let's check it. Okay, so this equation where f of x equal to f of x, okay, which is equal to x to the power of 1 by 3, and if we plot that, we observe that the equation is continuous, okay. So it seems there is no issue, but let's plot f prime of x, and this is f prime of x. So if you see at x is equal to 0, it shoots up, okay, shoots up, and it blows up. Because of this reason, there is an issue with the uniqueness, okay. There is a problem with continuity at x is equal to 0, so there is a problem with the uniqueness. Therefore, this doesn't have a unique solution if the initial condition is 0, but it's only for that particular initial condition. Otherwise, it will have a unique solution. If you check for other point, okay, it will have a unique solution. Fine. At least let's say if I consider x naught is equal to 2, it will have a unique solution at least near that, I mean an open interval near to x2, sorry, near to 2, okay. So that's what we learn from this existence and uniqueness theorem. Okay, in the book they have given one example related to this existence and uniqueness theorem, and they have given one function, and they have asked whether the solution exists and the existing solution is unique for all possible initial values, okay. So that's what this example discusses. So you just go through this example. Fine. So that's all about the existence and uniqueness, and in the next video we'll discuss about the impossibility of oscillations for one dimension. Okay, thank you.